Hi everyone, today we're going to do a practical. It's an efficiency practical, but it uses the specific heat capacity equation. What I basically want to do, to start with, obviously, I'm trying to get practicals in that you can do at home because we're telling you at school, don't spend 6 hours a day on your screens, and then when there's lockdown starts, we say, spend 6 hours a day on your screen. So I'm trying to kind of put in some other stuff that you can do. So we've got this practical that we're going to do. So it uses the specific heat capacity equation from last lesson. Also uses the efficiency equation from year 9. And actually, specific heat capacity, you did it in year 9 anyway, probably as well. It kind of comes up twice, but it's something that we need a lot of practice with. Normally, in my experience, students need a lot of practice with it. Something about that equation, just having 4 quantities in one equation, that kind of that gets people sometimes, I think. But so we're going to use specific heat capacity equation and the efficiency equation. We're also going to use the power equation and we're going to measure the efficiency of a kettle. The power equation you learned in year 9, but also you would have learned or recapped it in the electricity module as well. It's just that power is energy divided by time, or that energy is power times time. Anyway, I've written it all down on a sheet, and hopefully you can follow that through and calculate the efficiency of your kettle. Okay, so this is my kettle, and first off I'm going to empty the water in it, because I need to know exactly the mass of water that's in this kettle when I'm running my experiment, and also because I need to find out the power of the kettle. And to do that I probably have to turn it upside down. Oh look, there's the label. I hadn't actually done that before, so lucky it is. Because I'm looking for the power of the kettle, and if you can see there on the line where it says 220 to 240 volts, and of course mains electricity in the UK is 230 volts, so that's in that range. And then it says 50 or 60 hertz. Well, we've got a supply of 50 hertz frequency supply in the UK. And then to the right of that, it says 2,520 to 3,000 watts, and that's the power of this kettle. So the first thing is find out the power of your kettle. So because I had a range, I'm going to choose a value that's in between that. I'm just going to take an average essentially. Okay, so I'm going to go for 2,750. It's not quite an average, is it? Maybe I should do 2,760. That'd be a perfect average of those two values, I think. Well, I've just done that in my head. And the units are watts. So after this kettle's boiled, the useful energy store, which is in our equation for efficiency, the useful energy output is going to be the energy that's stored in the water, the thermal energy stored in the water. So I'm going to measure that using the specific heat capacity equation. And the specific heat capacity equation is E equals mc delta theta. M is the mass of, E is the energy, so we're trying to find the energy so that we can put that in our efficiency equation. M is the mass of water, so I need to know the mass of water that's in this kettle in our experiment. C is the specific heat capacity of water, and I'm going to tell you that. You can look it up on the internet. It's just a property of water. And the delta theta is the change in temperature. The change in temperature is going to be between the temperature, start temperature of the water, and the final temperature. The final temperature we're going to say is 100 degrees, because we haven't got a thermometer. It'll be almost 100 degrees anyway, so that's pretty bang on. And the starting temperature we're going to say is 20 degrees. It's round about right. So it might be a little bit colder than that in the winter, but let's just say that the starting temperature of our water is 20 degrees. So whilst I could literally weigh the water and get a kilogram of water by doing that, what I'm actually going to do is I'm going to use this property of water that a litre of water weighs 1 kilogram. What I said to you in the density video, if you remember, is that a centimetre cubed of water, or 1 millilitre of water, they're the same thing, has a mass of 1 gram. So in a similar way, 1,000 millilitres, a litre, has a mass of 1,000 grams, a kilogram. So a litre has a mass of a kilogram. So I'm going to use a measuring jug to make sure I've got exactly 1 litre of water in here. And this is half a litre measuring jug, so I'm going to have to do it in 2 goes. So I actually do have a thermometer, which I stole from school. Actually, I stole it from the Howard of Effingham when I used to work there, don't tell them. We're actually at 21 degrees, which is surprising because I kind of thought this would be a bit colder. But we're still going to use, I'd still like everyone to use 20 degrees for the starting temperature, initial temperature. So I've got this way that I'm going to work out the useful energy, which is the thermal energy stored in the water after it's boiled, which will be the mass of the water, which is 1 kilogram, times the specific heat capacity of water, which is 4,200, multiplied by the temperature change. It's going from 20 degrees to 100 degrees, so I let you work out the temperature change for yourselves, but it's just a simple subtraction. So that will give us the energy stored in the water, and that should actually be the same for everybody. So you could compare notes with people if you wanted to. The energy that we're putting in, though, the input energy, we're going to get from the power of the kettle multiplied by the time that we're going to have the kettle on for, because energy is power times time, if you remember that equation. So we know the power, but we do need to time how long it takes to boil before we can do any of our maths. All right, so get a timer up on your phone and boil your kettle at this stage. And once it's boiled, you stop your timer, you can write down all of your numbers, hopefully in a logical order on the sheet that I've given you, and find the efficiency of your kettle.